Yes, hello. How are you? How's everyone? In today's lesson, we are going to look at the classes of the IP because our IP addresses are divided in different classes. So, but before we start with this, let's look at what an IP address is. What is an IP address? So, we are saying an IP address is a unique number that is used to identify any devices that are connected or that have joined a certain network. So, for these devices to be identified on the network, they need to be assigned a unique number that is called an IP address. The IP address are unique. The word unique means they are not the same, they are different. So each and every device on the network is given a different number or a unique number. Okay. Now moving on to the different classes of the IP address. We say introduced in 1981 with classful routing IP. With classful routing, IP version 4 classes were divided into 5 classes. So with IP addresses, we've got different versions. We've got two versions. We've got the IP version 4, and we have IP version 6. But currently, the one that is being used is the IP version 4. But as we are moving on in this world, we might change, or it's a possibility for us to change to IP version 6, because with IP version 4, the IP addresses are becoming less compared to the number of devices that are being produced around the globe. So they are becoming less and less and less. So, but with the IP version 6, it have got a limited. It can support as many devices as it can. So, but with IP version 4, it have got only a certain number of, or it can only have, we've got a limited number of IP addresses. Okay, now coming back to the different classes of the IP address, we have got classes from A to E. So looking at the first class, which is class A, excuse me. In class A address, the first bit of the first octet is always 0. Thus, class A ranges from 0 to 127. So, but the actual range of class A addresses is from 0, it's from 1.0.0.0.0 to 126. So that is class A. If you look at the IP address itself, it have got octet. So we've got the first octet, the second one, the third, and the fourth. So each and every octet here, it equals to 8 bits. So this one represented, this is in decimal, but now if you represent it in binary, it becomes 8 octets. So that's why we say we have got the IP address, the IP version 4 address, it's 32 bits. So if you take 8 times 4 will give you 32 bits. So each and every octet have got 8 bits. And the range of class A, it ranges from 1 all the way to 126. So that is class A. So if you find an IP address with maybe 10.0.0.0.0, that is class A because it starts from 1, or 10 between 1 and 26. So meaning the first octet here is the one that determines which classes is the IP address. So in this case, if we have 125, then still 125.55.55.55.55. So you look at the first one, the first octet here. If it's between these ranges, 1 to 126, then that IP address, it's a class A. So moving on to the next one, which is the class B. Class B starts from 128 to 191. So remember, class A we said is from 1 all the way to 126, and then class B is from 128 to 191. So if an IP address is 129, 130, all the way to 199, 191, that is class B. Okay, so but now remember we said class A is from 121 to 126, and class B starts from 128. Where is 127? So 127 is reserved, it's for Lubeck, right? Moving on to the next class, like this is an example of a class C, of class B IP address. So because it's between 128 and 191, so this is 172. This is a class B address, IP address. Class C starts from 192 to 223, because class B ended at 191. So class C starts from 192 to 223. So anything between these ranges, then it has to belongs to class C. If we look at this one, we have it's 192, so this is 192. It's class C because it's in between 192 to 223. And then we have got class D, which is used for multicasting. And in class D address, the first octet is always, so we are using class D is for multicasting. Okay, so and the range is from 224 to 239. Right, this is an example of class C or class D IP address from 224 to 239. So anything that has or anything between 224 to 239 belongs to class D, which is used for multicasting. They are mostly used by the routing protocols like OSPF, RAID, and so forth and so on. And then we also have got class E, which are reserved for research purposes. So class E addresses are reserved for research purposes. So those ones are not used. They are for research purposes. And they range from 240 to 2555. 255. So that range, or all the IP address in that range, belongs to class E. Now, looking at the different classes here, we have got each and every class also has its own sorry my place. It have got its own subnet mask. Class A, the subnet mask of class A is 255.0.0.0, and it can support so when you subnet any class A IP address or net IP sorry please, it can support over 16 million addresses. And then moving on to class B, the IP, the subnet mask for class B is 255.0.0, and it can support over 65,000 IP addresses. And class C, which is mostly used by small organizations, it can support 254. Okay, and the subnet mask for that is 255.255.255.0. Now, if you look at this number of hosts here, or IP addresses that can be generated in each of the classes. Now, if you have got a class A IP address, if you subnet it, this is the number of IP addresses that you'll be getting. Same applies to B, class B. Same applies to B, to C. Now, what if I want to require 2000? So where does 2000 fall here? Then it's not catered for. Now, one way to address this situation will be to provide a person with class B network. So let's look at class B network. Okay, maybe you will get 2000, because this is where the 2000 falls. This is 65, and then for 2000 we need 2000. So 2000 falls here in class B. But that will be a waste of addresses, because you only need 2000, but class B can go up to 265,000. but it will result in a waste of so many addresses. Okay, this is what we have said initially. But and then another possible way is to provide multiple classes of C networks. Now, for you to get to 2000, then you need to have multiple classes of class C for you to get to 2000, because this is 254, and then you need a number of them, so many addresses for you to reach 2000. But that too can cause a problem, as there will be many networks to handle. So if you want 2000 out of this, imagine how many networks are you going to create. So many networks, and that also create a problem, because you need to handle, you need to take care of all those networks that you have been created, those subnetworks, for you to get 2000 IP addresses. Another possible way is to provide multiple class. Yeah, that's what we said. Now, to resolve the problems like the one mentioned above, the CID, the CIDR was introduced. So what is CIDR? CIDR is a classless inter-domain routing, whereby CIDR replaced the whole process that we just talked about. So with CIDR, in CIDR's subnet mask are denoted by slash number. In this case, is represented by X. For example, a subnet mask of 255 will be what? Will be denoted by slash 24. So the subnet mask for 255.255.255.0 is slash 24. So how did you get this 24? It's by changing or converting all these 255 into binary. So 255, it gives you 8 ones. Dot 81. Then you count all those active, all those ones. There are 24. And then it's a 0, so the 0 remains as it is. So we denote CIDR notation this way. So we say slash 24. So if you come here, if you look at this subnet mask here, so it's 255. So it means it's slash 8 slash 24. I mean, no, slash 16 and slash 24. So now these ones are constant. You can change this, and we can change, but so if you want either to increase the number of addresses here or to decrease, then you can just play around with the subnet mask by changing the subnet mask, which maybe this case you can change it to any of your choice, maybe 29/29/28, and that also allows you to either have less IP address or many IP address according to your needs. So this is basically what CIDR notations actually does. If you look here, for example, inside a subnet mask like this or that can exist. So this subnet mask can exist. Okay, so the first 8, and then you change this again into all ones. You convert this to binary, and then you count all those ones, and then you add to the first one, which are 8, and then that becomes your slash what, and then you just subnet from there. Now, looking at the IP address itself, the class of IP address is used to determine the bits used for network ID and host ID. So if you look at the IP address, there are two parts. We've got the network ID and the host ID, and the number of total networks and hosts possible in that particular class. So looking at these classes here, or these IP address classes, we have the network ID. If you look at class A, the first bytes, the 8 bits, they represent the network, and the others, the rest, represents what? The host. Okay. So that's why in the class A here we have got so many IP addresses that are generated, because many bits are used to represent hosts. And then if you come to class B, we have got network ID. Here they are equal. So 8 by 8. I mean 16 by 16. So the network ID, the first 16 bytes represents the network ID, and the next one represents the host ID. Now if you move to the next one, which is class C, it has so many networks but few users in that specific network or in that classes. So we have got many networks in class C, but the usable IP address are less. If you just check here, check on this green area here. Okay, and then class B we said is class D we said is for multicast address, and class E is reserved for future users or for research purposes. Okay, so that is it for today's lesson. I hope you guys should get it. You understand what the different classes of the IP addresses are, and the side annotation very important. So see you in the next lesson.